Hello. Before we begin this video, I suggest you firstly watch the previous video I made for simple Gaussian elimination. There I explained some basic stuff essential for performing the Gaussian elimination, like when to use Gaussian elimination, how to write a system of linear equation in the form of matrices, the types of elementary row operations you can perform to a matrix, and how to form the augmented matrix of a system of linear equations. If you are not familiar with these, I think the previous video will be helpful. Gaussian elimination is divided in two steps, one forward elimination, where the augmented matrix of the system is transformed to an upper triangular form, and two backward substitution, where the unknown variables are computed to find the solution of the system. As said in the previous video, the elements of the main diagonal of the matrix are called the pivots. We use them to perform row operations to transform the matrix to an upper triangular form. If one of them is 0, we must firstly fix this issue and then continue with the method. It's best to take measures to avoid this problem from the beginning, rather than face it during the method. To do that, before each step we swap two rows so that the element with the highest absolute value is our pivot. Let's see an example of a 3x3 system of linear equations. Firstly, let's write our system in the form of matrices and then form the augmented matrix. Now that we formed the augmented matrix, let's begin the forward elimination by performing elementary row operations in order to transform the augmented matrix to an upper triangular matrix. For this reason, we multiply the first row with the needed numbers and subtract it from the other two in order to transform the numbers of the first column to zeros, as shown. The rows are represented using the letter R, and the exponents in the brackets represent the step we are performing. As you can see, the pivot which is going to be used to continue the method located in the second row and second column is equal to 0. This is a blocking point for the method, as we cannot perform similar elementary row operations to transform the number below to 0. The method cannot continue. Let's see a different example, but this time we will take the right precautions to not face a similar problem. Before we begin the method, let's swap the third row with the first, as 24 has a higher absolute value than 12. Now we are ready to begin. We perform the needed row operations in order to transform all numbers below 24 to 0, as shown. Now we see that 10.5 has a higher absolute value than 5.25, so we swap the third row with the second. Now we continue the method by again performing the needed row operations to transform the matrix to an upper triangular matrix. The matrix is finally transformed to an upper triangular form, therefore we are now ready to perform backwards substitution and calculate the solution of the preliminary 3x3 system of linear equations. The backward substitution is performed as shown.